When we're using row operations to solve a linear system, we need to know when to stop or what our goal is going to be. The answer is reduced row echelon form, or RREF. Reduced row echelon form is the simplest form of the linear system that can be obtained using row operations. Not every matrix reduces to the identity like in the example that we saw before. And in these cases, reduced row echelon form is the closest that we can get. Sometimes we do get the identity, but not always. In cases when there's no solution or infinitely many solutions, for example, we're not going to have the identity. Every matrix can be put into reduced row echelon form with row operations. And it's unique. So in other words, if you and I both take the same matrix and we do different row operations and try and put it into reduced row echelon form, by the time we're done, the reduced row echelon form that you obtain and that I obtain will look identical. They will be the same. And the reduced row echelon form gives insight into the linear system. So in addition to just finding the solution, it might reveal some characteristics about it. So what is this thing? The definition for reduced row echelon form is that a matrix is in reduced row echelon form if the following four conditions are satisfied. First off, each row that you look at, the first non-zero entry in the row, reading from left to right, needs to be a 1. This one is called a pivot, the pivot. And so each pivot has to appear to the right of any pivots above it. We also need that any row that only has zeros in it should be at the bottom. And we need that any pivot is going to be the only non-zero entry in its column. Okay, so let's dig in and look at some examples here. Say we've got 1, 4, 2, 0, 1, 3, 0, 0, 1. Is this in reduced row echelon form? So we'll go through the steps. Let's see. So we check first off number 1, and we look and we say, okay, the first thing we see looking along here, is it a 1? Yes. The first thing we see looking along here that's non-zero, also a 1. The first thing we see looking along here that's non-zero, also a 1. Okay, so rule 1 is satisfied. Let's go and look at the next one. So each pivot appears to the right of any pivots above it. Okay, well, I just circled the pivots on my previous step, and so this this pivot right here appears strictly to the right of the pivot on the line above it, which is this one. And the pivot in the third row appears strictly to the right of this pivot, and hence also of this pivot. So that tells us that the second condition is also verified. Then any row of zeros is at the bottom. Since there is no row of all zeros, this one's trivially satisfied, so that's fine. Now, what about each pivot is the only non-zero entry in its column? Well, this first one is definitely the only non-zero entry in its column. But when I go to the next pivot over here, it's not the only non-zero entry in its column because of this 4. So that tells us, oh, all right, we still have work left to do. And similarly, if I look at this third pivot right here, there's all kinds of things that are non-zero in its column. So this thing is not in reduced row echelon form. So it failed number 4. Okay, so let's see then. So how would we put it in reduced row echelon form? Well, when I see a matrix that looks like this, the first thing that jumps out at me is that this row here is extremely handy because it has zeros everywhere except in one position. And that means I can use this matrix to kill off all these entries in the column above it. So this 2 and this 3, they are marked for death. So in other words, if I do row operations, and I'm going to do a couple row operations at once. Let's see. So I will do keep that one as it is, and I'm going to do -3 copies of row 3 to row added to row 2, and that'll give me 0, 1, 0. And I can do -2 copies of row 3 added to row 1, and that'll kill off the 2. So I have 1, 4, 0. Now everything is looking great for this pivot. So this guy here is the only non-zero entry in its column, but we still have to deal with this 4. However, since I've cleared up these entries over here, that'll be very simple, because now we have that this second row is a useful tool, because it has only one non-zero entry right here. So I can use this to get rid of the 4, and I don't have to worry about messing things up over here or messing things up over here, because the only other things in this row are zeros. So I'll do another row operation, and let's see, so I'm going to do -2 row 2 added to row 1, and that gets me 1, 0, 0. And then we have 0, 1, 0, 0, 0, 1 from before. And at this point we see, oh, this one did row reduce to the identity. So it turns out that the reduced row echelon form of this one is the identity. Let's look at some other examples. So 1, 3, 0, 0, 0, 0, 1, 3. And 0, 1, 2, 0, 0, 0, 0, 0, 0, 0, 0, 1. And 1, 2, 3, 0, 0, 1, 0, 0, 0. Okay. And actually here, sorry. 4, 2, 3, 0, 0, 1, 0, 0, 0, 0. Okay. Figure out which of those are in reduced row echelon form and which aren't. And for those that aren't, put them into reduced row echelon form. And I'll do that in the next video.